At the stop band omega, the squared magnitude HAJ omega p squared must be less than delta S squared, the stop band deviation, and the magnitude response is based on this equation, where this magnitude, the squared magnitude, must be less than delta S squared. Therefore, after we rearrange this equation, we have this Chebyshev polynomial function T(n) squared must be larger and equal than delta S inverse squared minus 1 divided by epsilon squared, where this epsilon squared is actually equal to this equation, and this whole equation is actually equal to 1 over d squared, where d is the discrimination factor. Therefore, the polynomial Chebyshev Tn must be equal and larger than 1 over d, the discrimination factor. Since the ratio of omega stop band to the ratio of omega pass band is equal and larger than 1, so based on this function of cosh and inverse cosh, delta omega S divided by omega p is equal and larger than 1 over d, the discrimination factor. Therefore, n is larger and equal to the inverse cosh 1 over d divided by inverse cosh 1 over k, where this function is actually related to k, and after we rearrange this equation, we have 1 over k at the denominator of the filter order equation. In designing the Chebyshev filter, we summarize the steps required as we have in Butterworth filter. So first we calculate the discrimination factor D, and then we determine the selectivity factor K. After that, we need to solve for filter order N, and also in this case we have another equation which is Chebyshev polynomials T and X. And then we compute the epsilon squared, the parameter that controls the passband ripple amplitude, and we have the synthesized system function based on the squared magnitude of the frequency response, where we determine in S domain, where S is equal to the J omega, which is, this is the transfer function in S domain. The next one, we select the left hand side poles, where based on this one, it is the production with limitation from n equal to 0 until n minus 1 for left hand side. Based on the pole of the filter, which is type 1, we have all pole in the filter, and for HA0, it is equal to 1 over cert to 1 plus epsilon squared if n is even, and we have HA0 equal to 1 if n is odd for this function HA0. And lastly, we have to proceed do the digital filter and frequency transformation from S domain to Z domain to frequency domain.